Hello everyone, I welcome you all in the course Introduction to Sequence Stratigraphy, and we have started discussing on the basic concepts of different sequence stratigraphic elements, and in the last class we have just gone through a brief outline of these different elements. So, we will continue this discussion, and in this particular class we are going to discuss about some other basic ideas about the sequence stratigraphic elements, where we will try to look into the arrangement of these different sequence stratigraphic elements within different types of sequence. So, basically we will try to understand that how different types of sequence are defined in sequence stratigraphy. So, as we already know that the sequence, it is the fundamental stratal unit in sequence stratigraphy, and commonly we correspond this to the depositional product of a complete cycle of base level change. That means at least there should be one complete cycle of base level change, or there may be multiple such cycles, or we can see at least one cycle of shoal line shift depending on what type of sequence model we are using. Since the start of this concept historically, when this concept of sequence and sequence stratigraphy started growing long back in 50 years, 70 years back from now, this idea of sequence gradually developed. So, I will not go into that historical part over here, but with time different types of sequence were defined by different workers. Some of the sequences, they were defined based on unconformity to another unconformity. Some of the sequences were defined based on the arrangement of transgressive and regressive packages of strata, like this. So, it was mostly based on what was the aim or objective of the work, or it was mostly based on how the packages were defined, how the packages were preserved in the rock record, and how people tried to interpret them in terms of their occurrences. So, whatever be the name of that particular sequence, the basic elements in terms of the system strats and the boundaries of the system strat or the sequence boundaries, they remain unchanged. What changes is the arrangement of these elements in different types of sequence. So, broadly we can define three major types of sequence. This is based on the concept that has gradually evolved by different workers from time to time. So, without going into that historical part in terms of years that how they have evolved, straightway I can give you a broad idea about what are the different types of sequence. So, the type 1 sequence, which is the most common one, is called as a depositional sequence. What is the meaning of this depositional sequence? We will discuss about that. So, this is the type 1 sequence which is called as depositional sequence, and also people have defined several variations within depositional sequence with minor changes as the idea got evolved, and also based on from which area this is defined. So, we get depositional sequence 1, depositional sequence 2, depositional sequence 3, like this it has evolved gradually. The second type of sequence is called as a TR sequence or a transgressive regressive sequence. So, as this name is suggesting, transgressive regressive sequence, so definitely it will look into the transgressive regressive packages of strata. As in the last class we have seen that when these system strats were defined, so there are transgressive system strat which is defining the transgressive part of the package, and there are regressive system strats which includes several types of system strats. So, when this name comes as TR sequence, definitely it looks into dividing the package or arranging the package in terms of transgressive regressive cycles. And the third one is called as a genetic stratigraphic sequence, or simple a genetic sequence. Genetic stratigraphic sequence. So, this is the third type of sequence in sequence stratigraphy, where normally the arrangement of the surfaces and the system strats are different from these two. How they are different? We will discuss about that in this class and also in the next class. So, when we are talking about these different types of sequence, we have to go back to that diagram, we have to go back to that concept of these different elements of sequence stratigraphy and their arrangement in terms of an ideal base level curve. So, I will refer to this diagram. This is a very well known diagram where these different types of stratal packages, different types of sequence elements are shown over here. So, first I would like to explain this diagram to you in a simplified manner, and then we will understand that how these different types of sequences are identified or defined. So, here in this particular diagram, this red curve indicates the base level curve, and very close to that particular curve we have another curve, that is a blue dashed line curve. This blue dashed line is the transgressive regressive curve, and already we know that these two are not juxtaposed, they always show little bit phase out condition. So, we can see that the peak of transgression, say for example over here, is not matching with the peak of the rise of the base level. So, this is the rise direction of the base level, this is the fall direction of the base level. So, accordingly we are getting transgression and regression in different parts. So, this is exactly the same diagram that we have already discussed in our previous class, just it is oriented in a different way. So, now the time axis is vertical over here. So, with respect to this particular curve, what we are getting in this part, so definitely this point, if I start from here, this part of the curve, this is the transgression part. So, definitely this is part of a transgressive system tract, that is the TST. So, this boundary, this dashed line is the maximum flooding surface. We know that above the maximum flooding surface always we will get HST, which indicates the peak of the base level and start of the regression. So, we will get a normal regression over here, and it is ended by a surface BSFR. After BSFR we get the base level fall, and during this fall what we get is a forced regression. Forced regression is mentioned over here by FR. So, this forced regression part in the shallow marine environment will be demarcated by systems tract which is called as FSST, that is the falling stage systems tract, and it will end up with this particular surface, the correlative conformity surface. Now, during this phase, if I look into the non-marine environment, that is the fluvial part which is associated with the base level change, in that part what we will get, the HST is directly overladen by a time gap which is represented by a bypass or erosion, and will come up with a subaerial erosion. So, subaerial erosion or bypass is represented by unconformity. So, that unconformity is represented through this heavy red line over here. So, this entire phase of FSST, which is demarcated by BSFR and CC at the bottom and top respectively, it is represented by an unconformity over here, just one erosional surface at the non-marine part or towards the marginal marine part. Above that we get LST, the normal regression when base level starts rising, and with that we get the end of the regressive phase. So, that marks a new surface, that is the maximum regressive surface, above which we get the transgressive systems tract. So, the transgression starts. So, always this transgression part will be represented by a fining upward succession. Before that, this entire portion will be represented by a coarsening upward succession. So, that coarsening upward part will continue up to this LST, and in that way it will go on again, repeat itself. So, this cycle will go on. So, if I look into the non-marine environment, this unconformity will be overladen by LST followed by TST followed by HST, and if it is a completely fluvial environment, then in each of the cases we will get a fining upward succession. How, why this will happen, this we will discuss later on in when we will discuss in detail about each of these systems tract, then I will explain that. So, what we are getting over here, arrangement of these different systems tract bounded by these different surfaces. So, based on how we are recognizing them in the rock record and how we are arranging them with respect to this base level change and the TR curve, we can define different types of sequence now. Say for example, when we are looking at the correlative conformity to the next correlative conformity, this one, from one correlative conformity to the next correlative conformity, and there all the packages which are present in between them along with all the boundaries, that entire package will be called as a depositional sequence, starting from one correlative conformity to the next correlative conformity. So, here we are getting several systems tracts and several boundaries covering up these systems tracts. The same depositional sequence can be defined in the marginal marine part or into the fluvial part in terms of the depositional package present from one unconformity to the next unconformity. That means one erosional surface end of the erosion to the next erosion. So, it is actually defining the package which is deposited between two major erosional phases. So, that package will be called as a depositional sequence. On the other hand, if I want to define a transgressive regressive sequence, then I will look into the transgressive package followed by the regressive package. So, in that case I will start from here, this green line that I am drawing over here. So, from this point onward the transgression is starting. So, this boundary is the maximum regressive surface. So, from there the transgression is starting and then it is ending up with MFS followed by the entire regressive phase starting with normal regression, forced regression and another normal regression. So, that last normal regression will be ended up by another maximum regressive surface or MRS. So, up to this mark, this entire portion will be defined as one TR sequence or transgressive regressive sequence, as it is defining a transgressive followed by an entire regressive package. The same can also be defined into the continental side, into the non-marine environment towards the marginal marine part, again in terms of transgressive package followed by the regressive package. And in the regressive package, since a major part is represented by erosion or bypass, so very commonly it is represented in terms of RST. So, a TST followed by RST together will produce a TR sequence towards the non-marine part or towards the marginal marine environment. Whereas, in the shallow marine environment we get a complete TR sequence preserved starting from one MRS to the next MRS, starting with TST at the bottom followed by HST, FSST and LST. That marks the end of that particular sequence. In the same way, if I want to define a genetic stratigraphic sequence, the boundary become different. In that case, we try to define in terms of a maximum flooding surface, this yellow circle that I have made over here. So, this is the boundary and from this boundary it starts with an HST followed by FSST followed by LST and then it will end up with the TST. So, initially it is a regressive package up to this point, followed by this point, this is the transgressive package. So, basically it is a regressive transgressive package bounded by maximum flooding surface at the bottom and the next maximum flooding surface at the top, and in between them we are getting HST followed by FSST followed by LST and then finally a TST, which is again covered by maximum flooding surface. So, that kind of package, when we are defining a sequence in this order, it will be called as a genetic stratigraphic sequence. So, a genetic stratigraphic sequence basically indicates the regressive package first followed by the transgressive package, where we are marking the boundary from one MFS to the next MFS. So, from this particular diagram, apparently what we can understand is the names of different sequences that was proposed by different workers. It is entirely arrangement of these different sequence elements. The sequence elements in terms of the system strats on the boundaries, they remain same, they remain unchanged. What varies is how we are defining them, how we are arranging them in order to define that particular sequence. So, in this class we will look into the depositional sequence, and in the next class we will discuss about the genetic stratigraphic sequence and the TR sequence. The various sequence stratigraphic models mainly differ in the style of conceptual packaging of the strata into the sequence, that is with respect to where the sequence boundaries are picked up and they are placed in the rock record. So, the nomenclature and the definition of system strats, they differ among the various sequence models, but invariably the timing of each system strat and their boundaries corresponds to one of the four major events in the base level cycle. Those four major events that we have defined in the last class while we are defining the boundaries, that is the start of forced regression, end of forced regression, the end of regression and end of transgression, end of regression with start of transgression and end of transgression with start of regression. So, these are the four major events which occurs during a base level cycle, which help us to demarcate the boundaries, the surfaces and help us to demarcate the system strats in between them. So, when we look into the depositional sequence, there we commonly use the subaerial unconformity as the main boundary. Please refer back to the diagram that I have just explained to you in this class. So, we start from subaerial unconformity to the next subaerial unconformity. So, when we are talking about a subaerial unconformity, it is actually the last phase, the last erosional record. So, maybe if you have this much of package available over there and then it is going through some subaerial erosion. So, there is no record of that erosion, because when something is eroded, it is gone, it is removed from the system. So, what we get finally is the last surface after that erosion. So, when we are defining a subaerial unconformity within a package, that means we are defining that last erosional event in terms of time. So, definitely that last erosional event will have a corresponding surface in the basinal area, particularly in the marine basinal area, where this erosional event which is related to falling of the base level should have a correlative conformity. So, when we are defining the subaerial unconformity as the boundary for depositional sequence, its corresponding surface in the basinal part, which is represented by a correlative conformity, will also act as the bounding surface for a depositional sequence. So, definitely identifying a correlative conformity surface is quite difficult, because it is within a conformable succession, and within that we have to define a correlative conformity until and unless we have the corresponding unconformity defined in the landward side. So, normally or very commonly, depositional sequence is defined from the continental side or towards the marginal marine side, where during the falling stage of the base level clearly we get a subaerial unconformity. So, now this subaerial unconformity, when this particular surface is marking the end of the erosion. So, after that deposition started with rising of the base level. So, that entire depositional phase is represented in terms of a sediment package, in terms of different system strat which are arranged above that subaerial unconformity. And in terms of the base level curve, again what we are getting is a changeover from rise to the falling of the base level, and that falling of the base level will lead to the next phase of erosion. Again, we do not know how much of erosion is going on, what we get is the final erosional surface again. So, that is the next subaerial unconformity. So, what we get finally in the rock record? We are getting a package of strata which is the depositional package, and it is bounded by an unconformity at the bottom and another unconformity at the top, and it is very easily identified. So, the depositional sequence uses subaerial unconformity as the most easily identified surface to define a depositional sequence. Or very often, if the correlative conformity can also be identified in the basinal part, then that bounding surface becomes a composite boundary or a composite surface, where it is a continuous surface starting from subaerial unconformity to the correlative conformity in the basinward part. The timing of the subaerial unconformity is equated with the stage of base level fall at the shoreline. So, if I want to draw this depositional sequence, already I have explained to you, but to make it little bit more simple. So, in the continental side or in the fluvial side, this can be the unconformity. So, this is the unconformity in the continental side. So, on this unconformity, which represents the end of the fall and start of the rise of the base level. So, on that what we get is a coarsening upward succession of the LST package. It will be marked by the MRS surface. Then on this LST we will get a TST package which will be marked by MFS, and this TST will be overlain by another aggradational plus progradational package which is called as HST. And in this marginal marine area or in the non-marine part, this HST will be overlain by another unconformity. So, starting from one unconformity to the next unconformity, what we are getting is a complete depositional package. There is no erosion involved over there. unless there is some erosion along the bottom part of the TST due to some ravinement process. Apart from that, there is no chances of erosion within this entire package. So, this is a depositional sequence. Now, if I want to continue this into the basinal part, this unconformity will be continuing into a correlative conformity. So, when we continue this unconformity towards the basinward side, what we are getting over here is a correlative conformity. So, what is this correlative conformity surface? This is the end of the falling phase within the basinward side. So, definitely what we are getting over here below this is FSST, the falling stage systems tract, its deposit in the form of a coarsening upward succession, and this FSST will be overlain by LST, which will be completed again another coarsening upward succession, which will be ended up with an MRS surface, followed by a finding upward TST surface, TST package, which will be bounded by a maximum flooding surface. Then we will have HST over here as well, and this HST will be a coarsening upward aggradational plus progradational package, which will be overlain by a BSFR surface, and finally above this BSFR we will get a falling stage systems tract, which will be bounded by the next correlative conformity, which is actually equivalent to this unconformity surface. So, when we are looking into the basinward side, it is a much thicker unit, relatively thicker unit, or in terms of number of packages with respect to the systems tract, there will be more systems tracts, more surfaces, as it is a continuous conformable succession from one correlative conformity to the next correlative conformity. So, when this entire package is present from the marginal marine to the basinward side, then this surface becomes a composite surface, because in one part it is an unconformity, in other part it is a correlative conformity surface. In the top part again it is a composite surface, in one part it is an unconformity, in the other part it is a correlative conformity. And based on where we are looking at, the package of strata, the package of arrangement of the systems tract will be different. In the marginal marine part we will have only LST, TST and HST, there will be no FSST. Whereas, when you are looking in the basinal part, in the shallow marine part, there we can have a different arrangement. So, this is how a depositional sequence is defined from the rock record. So, it is from one unconformity to the next unconformity. The conceptual merit of depositional sequence is that the sequence boundaries are defined relative to the base level curve when the base level is falling, and hence they are independent of sedimentation rate. We are defining the unconformity surface which is forming because of erosion straightway. So, we do not have to think of how much sedimentation is going on, what kind of sedimentation is going on, it is irrespective of that. So, in later cases we will see that there can be some cases may arise that due to variation in sedimentation rate along the coastal area, some surfaces may give rise to some diachronity in terms of their appearances in the rock record, because maybe along the coastal area everywhere the supply of sedimentation cannot be at the same rate. So, maybe in one part sedimentation rate is higher, so there we can get a much thicker progradational package, whereas in the other part at the same time the sedimentation rate is slow. So, maybe the progradational package over there is a smaller one, and by the time it is forming the next surface has formed, next surface has appeared over there. So, the extent of these different packages may vary depending on this rate of rise and sedimentation rate, which is not the case in case of when we are defining the depositional sequence with respect to a base level fall, when we are defining the depositional sequence with respect to unconformity, because unconformity is related to erosion, it is independent of rate of sedimentation. So, subaerial unconformities form the most important type of stratigraphic surface, because it can be very easily identified. It is commonly associated with largest gap hiatus in the deposition and commonly separates the genetically related packages of strata. So, in the rock record we can very easily identify the subaerial unconformities, and more importantly we can trace them out very easily. So, depositional sequence may form over a broad range of temporal and spatial scale, depending on what is the scale of occurrence of the unconformity, that is how much we can trace the unconformity laterally, and temporally how much packages can be correlated. As we have already seen that unconformity can be defined in different scales in sequence stratigraphy. I will ask you to go back to our class on the concept of scale in sequence stratigraphy. So, unconformity of third order, unconformity of second order, accordingly we will define the sequence, depositional sequence of second order, depositional sequence of third order, and it can go on like that. So, when we are defining an unconformity and the package in between that unconformity, so they will share similar characteristics and they will require the same type of analysis for the recognition of bounding surfaces and the internal system strats. So, in that way depositional sequence of different orders in different hierarchy can be defined, can be arranged. So, the term depositional sequence is commonly kept independent of scale. So, it can be a second order depositional sequence, it can be a third order depositional sequence, it can be fourth order depositional sequence, and when we are defining a fourth order depositional sequence, we will define the boundaries with respect to unconformities of fourth order, and within that we will define the system strats of fourth order. So, the reference of this depositional sequence with respect to the scale is resolved by using modifiers such as first order, second order, and it can go on like this. So, this is the overall concept of depositional sequence. So, in this class we have tried to understand that what are the different types of sequence, how they are arranged with respect to the different occurrences of surfaces and the different system strats, how they are organized, and we have tried to understand what is the characteristic of a depositional sequence. In the next class we will discuss about the other two types of sequence, the genetic stratigraphic sequence and the TR sequence. So, these are some of the references that you can further study, further refer to. So, thank you everybody.